In the following video, we're going to examine how to use the elimination method to solve a system of equations. Now, this method is used when the variables or the terms in each equation are in the same order. That means if I were to have two equations, let's write down ax plus by equals c and dx plus ey equals f. To be in the same order, one way of thinking of it is to think your x's are above your x's, your y's are above your y's. Or you could have a system so you could rearrange the equation so that the variables and terms are in the same order. That means instead of, let's say I didn't have dx plus ey equals f in the bottom, what if I had ey plus dx equals f? Well, I could use my commutative property and switch these positions so that way they are in the same order. The bottom line when you're using the elimination method is put the x's above the x's and the y's above the y's. Make sure your variables line up vertically. And then what you do is you're going to multiply an equation by a factor to get one term, either the x or the y, to add to 0. Now there may be times where you might need to multiply both equations, and we're going to look at a couple examples like that. But the key here is they need to add to 0. So you need to ask yourself what types of numbers add to 0. So what types of numbers, if you add them, give you 0? Pick up a number. If I were to have 5, what do I add to 5 to give me 0? And the answer here would be I'd have to add -5. If I were to have 3, what do I add to 3 to give me 0? It'd have to be -3. So the key when you multiply an equation by factor to get one term out of the x or the y to add to 0, you want to create opposite terms. Opposite terms add to 0. 5 and -5 give you 0. 3 and -3 give you 0. So let's take a look. First, I have 3a minus 2b equals -3, and 3a plus b equals 3. So what I'm going to do is I'm going to see my variables are above each other. Now I want opposites. Now it doesn't matter. You could eliminate the x. You could eliminate, sorry, here the a or here the b. It really doesn't matter. You have to decide. One route might be easier than the other, but overall the same answer will be found. So if I want to create opposites, I'm going to go ahead and say I want to eliminate a. Well, if I have a 3a on the top, let's do this over to the side. If I have a 3a, I want on the bottom then a -3a. And that way, to add them gives me 0. Well, right now on the bottom I have a positive 3a. So to make this a negative, I'm going to multiply the entire equation by -1. So the top equation stays the same, 3a minus 2b equals -3. Now when I multiply the bottom equation by -1, you're going to distribute to all three terms, which multiplying by negative just changes all the signs. So you get -3a, you'll get a -b, and you'll get a -3. And now you add the two equations vertically. The 3a and the -3a cancel. You get -2b and -b, which gives you -3b. And -3 plus -3 is -6. And so then solve for b. B is 2. Well, now that I know b is 2, I need to find a. Now to find a, it doesn't matter which equation you plug into. You can plug in the top one, you can plug in the bottom one. The whole point is just to solve for a. Now I am going to plug it into the bottom equation, the one that says 3a plus b equals 3. But b is really 2, so I have 3a plus 2 equals 3. I'm going to subtract 2, so 3a equals 1, and then divide by 3, A is 1/3. And so write your answer as a coordinate. This time it's not x, y, but it's a, b, so we do them alphabetically. 1/3, 2. So when I did the elimination method, the whole point was to create opposite terms above each other or below each other, and they add to give you 0, so they eliminate each other. And then we focus on the variable that remains. So let's look at example 4. Now in this one, I see I have a 3x, a 2x, a negative 5y, negative 3y. In this example, we're going to multiply more than one equation. If there's nothing you can multiply 2 by to get 3, and you can't multiply 3 by something to get 2. So to use this, you kind of had to think, what is the least common multiple of my terms? And I'm going to focus on the x. I'm going to eliminate the x. So what's the least common multiple of 3 and 2? And so the least common multiple of 3 and 2, you have 3, 6, 9, 12, 15, 18. For 2, you have 2, 4, 6, 8, 10, 12, 14, 16. And so the first number, the first multiple they share of each other is 6. And so what that tells me is when I create my opposites, I want one of them to be 6x, and I want one of them to be negative 6x. That way I can actually add them to give me 0. So if I look at the first equation, 3x, if I want to make a 3x into 6x, I'm going to multiply the entire equation by 2. And that's going to give me 6x, distribute it to all the terms, minus 10y equals negative 8. Now I want the bottom equation to be my negative 6x. So I'm going to multiply by negative 3. So distribute it, you get negative 6x plus 9y equals, and you have negative 3 times 29. And so that's going to give me negative 87. And now that they're opposites, you can add them together. And so you get the 6x and the negative 6x cancel. Negative 10y plus 9y is negative y. And then negative 87, you have negative 8 minus negative 87 gives you negative 95. And then you divide by negative, so y is positive 95. So now the whole point is to find your x term now. So to find x, I'm going to plug it in. It doesn't matter which equation. I'm going to go ahead and use the bottom one. Bottom one says 2x minus 3y equals 29. So I have 2x minus 3 times 95 equals 29. And so you get 2x minus 285 equals 29. You're going to add 285 to both sides of the, which gives you 314. And then divide by your coefficient, divide by 2, and x equals 157. And so then I have my x and y coordinate. I have my solution, 157 and 95 as my coordinate. So one way you can know that your answer is correct is you can plug your answers in to the original system of equations and just make sure it yields a true statement that when you plug x and y in, you will get negative 4. You plug 2x minus 3y equals 29, you actually get 29 when you plug x and y in. But doing that involves making sure you multiply right, make sure you do the order of operations right. Now, if you are taking the test that allows a calculator, you can quickly check your answer by using your calculator. Just type in the systems. Do 3 times your x value here is 157. Subtract your 5y, which y was 95. If I were to hit enter, I do get negative 4. But you have to check both equations. So 2 times 157 minus 3 times 95. And now if I get 29 for this, that means my answer is correct. And so one quick way to check your answer is just to plug them in with the calculator and make sure you get the right side of the equations. I could do it for the original example we did as well. 3a minus 2b equals negative 3 and 3a plus b equals 3. Except for here, 3a, so let me clear this out. 3a is 1/3, so I can do 1 divided by 3, minus 2b, so 2 times 2. Now if I do this, I do get negative 3, so that works. Now let's do the other one, 3a, so 3 times 1/3 plus b, which b is 2. Now if I get 3 when I hit enter, that means my answer was correct. And so now I know that my solutions for my system of equations using the elimination method are both the right answers. So the whole purpose when you're doing the elimination method is to create opposites. Sometimes you only have to multiply one equation to create the opposites. Sometimes you have to multiply both equations. When you multiply both equations, make sure you use the least common multiple of the expression to make it easier on you. And then just make sure they are opposites. If one's positive, the other one has to be negative. And then you just add the two equations together, solve for the one variable, plug it into either equation in the system, and then finally get the other variable's value.